Unit 3, Lesson 1, Function Family Reunion. All right, in the first section, we're going to graph the graphs listed under A, B, and C, and I've done them on Desmos. So the first one, x squared minus 2, is going to take our parent function here and bring it down 2. So that's the blue one right here, down 2. And the next one is going to take our function and move it 2 to the right. That's the red one right there. And then, excuse me, the last one, 2x squared, is not going to alter the vertex, but it's going to change the slope of the sides to make it a little steeper. So that's the green one. So what just happened? So on the first one, x squared minus 2, our y-intercept changed from 0, 0 to 0, negative 2. Our x-intercepts, which originally on here were just 1 at 0, 0, they're now 2, 1 at 0, negative square root of 2, 0, and square root of 2, 0. Rate of change, the slopes of the sides stays the same. The next one, pretty much the same. It shifted over to the y-intercept is now 2, 0, or the x-intercept is 2, 0. The y-intercept is up here at what? 0, it's at 0, 4. On the first one, the y-intercept is the vertex down there, 0, negative 2. And the last one, 2x squared, that's the green one, still has the vertex at 0, 0. And the rate of change is now a little bit different, it's steeper. Okay, that's that one. All right, the next one, kind of the same philosophy. X cubed plus 3 is going to move our regular graph, regular as in this guy, up 3. So that's the purple, I guess, here. And what happened to that one is that the original x-intercept was right in here at 0, 0. Now we're at what? Over here at the cube root of negative 3. I guess that would be. The y-intercept is 0, 3. On part B, that moves us 3 to the left. So that would be this black one right here. The original one is right at the origin for the intercept, 3 to the left. This is over here. The y-intercept would be way up the graph there someplace. 0 plus 3, 3 cubed, so it'd be at 0, 27. We had to build a y-intercept for that guy. The rate of change is the same, so these two graphs in the first two, A and B, are the same shape. The last one, 3x cubed, is the red one, and that one just has a more pronounced rate of change. It's steeper, is the way I would put it. Okay, so into the set section, we're going to graph 2 to the x and 2 to the negative x, and I'm going to take a stab at doing this by hand. Excuse my lack of not accuracy, but just, it's not Desmos. All right, so h at x is 2 to the x, is an exponential function that comes up like that. It's going to hit at 0, 1. 2 to the negative x, when you take a function and you do at the negative x, that is a reflection of the y-axis. So this one, sort of like that. They should be mirror images in the y-axis. On number 4, our original graph is our parent function x squared. That's coming down around that away. And the next one, negative 1/2. I would think of that almost like 5 minus 1/2 of x squared. So the negative 1/2 is going to flip the graph, and then the vertex is going to change to the position 0, 5. Let's do this in a different color. We go 1, 1, 2, 3, 4, 5 up in here, and then we'll be opening downward. Set that equal to 0 and solve. You can get your x-intercepts. Doesn't say to do that in the directions. All right, the next one, 1 over x. This is a rational function. So this one's going to look, this one in red. It's asymptotic to the y-axis towards infinity. And it's also in quadrant number 3 over here. Okay, the opposite of x is going to flip that over the x-axis. I'll do this one in green. So the quadrant 1 will flip down to quadrant number 4, and quadrant number 3 will flip up into quadrant number 2. So the green is this guy, and the red is the 1 over x. All right, what's next here? Okay, number 6, your basic log graph here now. So a log graph is the inverse to an exponential. So the log of x comes up and bends around that way, and that is the inverse of 10 to the x power. Okay, so the next one is the log of x, basically minus 1. So it's not a whole lot of difference here. It'll be a little bit lower around sort of that away. So basically what's happened here is that every point on the graph that this was drawn with, Desmos, every point in the graph moves down 1. So on the x-intercept on the log of x is here, and then that's going to shift that point down into this position, and so on and so on. Kind of tricky. All right, the next one, sine graph. I'll get my black pen here. I'll put this out here. So what does a sine graph look like? The regular sine graph starts at the origin, reaches up here, comes back down, comes back this way, it comes up sort of like that. All right, so we know it tops off at 1. A little bit of an exaggeration over here. It's going to bottom out where at -1, right? So if we do this automotive scale, it'll come up into here and then down to there. Okay, so what happens on this one? Well, first of all, it has to shift back by pi over 3. By back, I mean to the left. And then the amplitude is now going to be increased to 2. So this graph is going to top off at 2 and bottom off down, say here, say at -2. And it's going to start at pi over 3. This is negative pi over 2 right here. So it starts, pi over 3 is a little bit smaller. So it's kind of in here. And it's going to reach up to the 2, down to the -2, back up to the 2, down to the -2. Again, as in most of the videos that I've been doing, I would suggest checking all of these on Desmos. All right, number 8. What we got here? And we got to fill out this table, right? So, where to go? We've got use the graph and table to write the rule for each function. Okay, so we got x cubed. There it is. And all the answers are already filled in there. Oh, we're supposed to find the rule, I guess. All right, so the first one, like that. This is x cubed, right? So on the next one, if we look at the table of values, and the directions say, use the graph and table of values. All right, so -2, 3 from -2, 8. I'm going down this column here. Notice that all the x values are the same, -2, -1, 0, 1, and 2, and they're the same in the regular x cubed function, but all the y values have what relationship to the original ones. You get -8 and -3, -1 and 4, well, obviously are 0 and 5. It looks like my xy has been transformed into xy plus 5. Okay, so that would suggest that the rule for that must be f of x is x cubed plus 5, because all the y values were incremented. Now on the next one, let's look at the x values first. -2 to -4, that's down 2. -1 to -3, that's down 2. So we get a lot of my x values going down by 2. So my xy is going to transform into x take away 2. Now let's look at the y values. The original ones were -8. Got -8. This one's actually different than the book. I'm looking at the book and it's got a whole different set of values in here. So it's -8, -8, -1, +1, 0, 0, 1, -1, 8, -8. I think there's a typo right in here that we're looking for -4, -8, because all the other y values, notice they're opposites. -1 here, +1 over there. 0 is its own opposite, 1, -1. So it looks like we've done what? Flipped it over, so that'd be a -y like that. So I would call this rule f at x is x plus 2 cubed. And I know that there's a minus and that plus might seem contradictory, but when you move to the left, the rule is x plus 2, not x minus 2. And then we flipped everything over the y-axis, so it should be a negative sign there. So in my textbook, this first point says -4, 64, -3, 27. So I'm not sure what yours looks like. All right. The next part is find the functional values. So this is a little break in the page here, but absolute value of x plus 5. When x is -2, that's going to be equal to 3. -2 plus 5 is 3. The absolute value of 3 is 3. When x is 0, it's going to be absolute value of 5, which is obviously 5. And 3 plus 5 is 8, and the absolute value of 8 is equal to 8. All right, on number 10, -2 minus 2 is -4. So the absolute value of that is 4. 0 minus 2 is -2. The absolute value of -2 is 2. F at 3 is 3 minus 2 is 1. The absolute value of 1 is 1. All right, a little different here. So this is going to be -2 times the absolute value of -2, which is going to be what? -4. 0 times the absolute value of 0 is obviously 0. And then 3 times the absolute value of 3 is going to be 9. So the absolute value returns the positive version of the value, and the absolute value of 0 is 0. All right, the next one's going to be 3 to the -2 power, which is 1 over 9. Next one's 3 to the 0 power, which is 1. And the last one here is 3 to the 3rd power, which is 27. On 13, that's going to be 3 to the -2 plus 2, -2, which is 3 to the 0, which is 1. And number 13, the next one's going to be 3 to the 0 plus 2, which is 3 to the 2nd, which is 9. And the last one here is 3 to the 3 plus 2, which is 3 to the 5th. So 3 to the 3rd is 27, 81, I guess that's 243. I'm doing my math right. All right, the next one's going to be 3 to the -2nd plus -2. And that is what? 1/9 plus -2, which would be what? -1 and 8/9. F at 0 is going to be 3 to the 0 plus 0, which is 1. And the last one here is going to be 3 to the 3rd plus 3, which is 27 plus 3, which is 30. Excuse me. Number 15 is going to be -2 over -2, which is 1 for the part A. 0 over 0 is undefined, so I'm not going to get any answer there. And 3 divided by 3 is 1. All right, the next one's going to be -2 over -2 minus 4, which is -2 over -6, also known as 1/3. Next one's going to be 0 over 0 minus 4, which is 0 over -4, which is 0. And for part C, I'll push over here. That's 3 over 3 minus 4. That's 3 over -1, which is -3. All without a calculator here, folks. We should be trying to do these mental math. All right, the next one, -2 over -2 plus 2 plus actually minus 5. So that looks like undefined because the minus 5 is fine, but you can't divide by 0. So that's undefined. F at 0 is going to be 0 over 0 plus 2 minus 5, which is 0 minus 5, negative 5. And F at 3 is going to be 3 over 3 plus 2 minus 5. That's 3 fifths minus 5, negative 4 and 2 fifths. And a couple more here. Okay, so the log of negative 2 in base 3. Well, the log of negative 2 in base 3. That would be undefined because, remember, this means 3 to what power is equal to negative 2. And the function 3 to the x is above the x-axis, and negative 2 is down here. So no answer for that one. And the next one, the log of 0 in base 3 is going to be 1. And the log of what, 3 in base 3. Actually, my bad. Let me back it up. The log of 3 in base 3 is equal to 1. This one here, pulls off to the side. That one is going to be what, the log of 0 in base 3. And again, that's similar to the first one. 3 to what power is equal to 0? Well, that can't happen either. So these two are undefined by that. All right, number 19. Now this one is somewhat obvious because of the way it's been written. Remember, one of your log rules is the log in any particular base, let's call it x, of x to some power. One of the rules for of logarithms is that a can, what I call, power down like that. And then the log of x in base x is equal to 1, so that goes out to a. So these answers are all going to be the value of x because the x can power down and the log of 7 in base 7 is 1. So this is going to be negative 2, 0, and 3. Not too bad there. All right, the next one is a little different in that x times the log of 1,000 in base 10. This part right here is equal to 3. So this function is basically 3x. So this will be negative 6, 0, and 9. A little tricky on that one. Remember, this part here means 10 to what power is 1,000. 10 to the x equals 10 to the third, so x equals 3. All right, so there you go. Unit 3, lesson 1.